Welcome back, friends and neighbors. Time now for another SSH, or I suppose time to complete the SSH video. It struck me at the end of the last one that I may have done you a disservice. We weren't explaining everything as I went along, so I thought I'd inject a couple of PSAs along with this particular video as we work through some stuff. Now we're almost at the end. SSH is installed. When you do the packages and you install them, there's a lot built in, and we'll go through some of that. The only thing that we're not going to do today is do the key generation, which is pretty straightforward because it comes with some keys and then you can just replace them. But without further ado, a little SSH on the configuration side. So the first thing that I want to point out is that in the previous video you saw me using a lot of CentOS 7 and a lot of CentOS 8, and I'm still doing that, but I use CentOS 8 and CentOS 7 distros because I just have them hanging around. I downloaded CentOS 8, but I wanted to make sure I pointed out something to you. So in this particular video, I'm going to make sure that we recognize that we're using CentOS 8 Stream. And the real difference between that is a matter of support. So CentOS Stream is what they're going to support going forward, and so the VMs that the ISOs that I brought down are based on CentOS 8 Stream. Now a lot of times I'll bring down a minimal build because they're smaller, they're easier to work with, and I don't do a lot with GUIs. I do a lot on the command line, and so I don't need a desktop or anything like that. You can always install a desktop if you want one, right? You can install GNOME if you really want to work with a desktop. But so that's one of the reasons why you'll see me work on the command line or on a VM that doesn't have a lot of desktoping associated with it. And for those of you who are not familiar with Linux at all, CentOS is another name for, or comes from, the Red Hat Enterprise Linux. So a lot of times you'll see the abbreviation or the acronym RHEL associated with that. And I provided the link here if you want to know really the difference between CentOS 8 and CentOS Stream. All right, what's next? Okay, so when you do your build, as I did last time, a lot of times we have the root install, and during the install I provide a root password, right? It was one of those things in the checklist: make sure your network is on, and then do a root password. At that time, you can also create a user, but that user is not what we call a super user. So that user, there's a lot of things that they can't do. And so there's this set of commands that sort of goes together: su, sudo, and sudoers, or sudoers, right? And so I thought I would just provide a little more detail on that. SU stands for super user, and you can SU as somebody else. So if you're a regular user, you can SU as somebody else. You could do SU root, for example. And that's because you want to do something that your permissions or privileges don't allow you to do. And so you SU as that user that does have those permissions, but of course you have to know the password for that user. Now, if that user is a super user, SU, that means that you can change your identity to be that person, or you can do it temporarily with the sudo command. Now that also means that that user, whoever that is, whether it's root or somebody else, has to be in the sudoers file. And so you can add a person to that file on the command line, or you can edit the file directly. And I just wanted to provide a little more detail about that, so you can actually look at the files and see who's in there. But that's how you tie those together. And so take a look at the man pages, but I just wanted to make you aware of that. All right, so here is my workstation 15.5 interface. And you can see that along the right-hand side, I've got a collection of CentOS 7, and then I've got the CentOS 8 Stream. Now the two VMs that I'm going to work with right now are the CentOS Stream. This is just going to serve as my server here. The GUI or the GNOME desktop that you would install with CentOS 8 Stream is a little nicer to work with than some of the earlier ones. And so we're going to deal with our terminal here. And I just wanted to point out a couple of things. first of all, is this particular IP address. It's 15.2, and here is my MAC address. Now that becomes important to us later on. And this is the machine that I installed OpenSSH server. So this guy has OpenSSH running on it, just like we did in the last video. And then I've got this stream client here. And I just named it client because this is going to be my SSH client, not because it's, you know, fundamentally different or anything like that. Whoops, let's try that again. I think I fat fingered it again. Oh, there we go. All right, so we've got a server running here. You know, we'll just SSH to that particular IP address. Now I could add, you know, the port number that I want to use, right? I think I just did it again. Ah, huzzah. All right, so if we do an ifconfig here, we can see that it's 15.32, which is the IP address of this particular machine. And so that sort of shows us that we have a terminal into that machine. So that's one way to look at it. If I exit, right, and I do an ifconfig again, we can see that this machine is 15.38, and importantly, I've got a different MAC address here. And like I said, that's going to be important to us. Now, when I did this SSH connection, this is clearly a command line version of the connection. And I would do all the things normally, right? I would run commands here. If I was going to do an install of some kind, I can do an ls, right? I have all of these things that I can normally do in a terminal. I'm just resident on the other machine. The reason that SELinux pops up is because what we're trying to do on a server is we're trying to allow connections in. One of the easy ways to do that is just to disable SELinux. The more complicated way of doing that would be to specify particular kinds of connections through and things like that. But a lot of times for testing and things like that, we allow connections through by just killing off SELinux. Well, when you see that pop up, what in the world are we talking about? Well, SELinux, or Security Enhanced Linux, right? It's just the security arm for Linux. And the whole name of the game here, which is a good idea, right, is to protect the system from certain kinds of connections, right? So you're allowing certain ports to connect and things like that. So as we can see here, this is the definition for, you know, sort of what SELinux does. We have to realize that on this Linux distro, you know, we've done the install, there's this security part of it that's there that will prevent us from connecting to a particular machine. Now the key to, you know, sort of shutting it down or allowing it is enforcement, right? So SELinux, we have this get enforce or set enforce, or some people pronounce it get enforce or set enforce. Okay, but SELinux really has, you know, the sort of binary relationship. Is it on or is it off? You can do that. And so when you set it to 0, right, you are in what we call permissive mode, meaning that you've sort of turned off all of its protections. And when you go the other way, right, you turn it back on again and you're enforcing whatever rules are there. And when we do the install, when it's enforcing, it's doing whatever was set up by default because we didn't change any of the rules associated with that particular distro. So I thought it'd be worthwhile talking a little bit more about this. Okay, so now the fabulous Gary Scarsborough, shout out Gary, pointed out something on YouTube that I forgot to mention last time. When you create a clone, it is exactly what it says. You take this thing and you make a copy of it, you have everything that thing was. Meaning that any files, any configurations that were in the original are now part of the clone as well. That includes keys and user files and configurations. So we're doing a video on SSH. And so that's one thing, right? So whatever keys we create on the original, or whatever keys are part of the original, they're carried over to the clone, right? It stands to reason. It makes sense. But another gotcha that's out there is the networking side. So here is an example where I've got my CentOS main VM. And we can see the IP address is 15.32. That's the one that I just SSH'd to. And we can see the MAC address here is, ends in 32C4. Now the clone that I created from that, now it's a full clone, but it doesn't really matter because I created this clone from this 64-bit streaming VM. Take a look at the MAC address. It's exactly the same, right? And so what happens is that it picks up the same IP address, or is, gifted with the same IP address when it moves over. And the problem, of course, is that now we have no unique way to differentiate the network connection that we're dealing with. And so we just want to be aware of this. Now, there are lots of reasons for keeping the VMs exactly the same. You might want to do that for a testing environment, or because they're part of an architecture that is load balancing or doing backups, something of that sort. But in this particular case, I'm using one as a client and one as a server. I don't want them to be the same. And so let's take a look at some of the configuration items that we have. Well, replicate the network connection state. That's just there so that my connection is still live when I move over. But the real important thing is this advanced tab here. And down here, we can see that I have the ability to use a different MAC address, or even generate a MAC address. So I say OK to this, and I take a look over here, and look at the MAC address is now changed, and so DHCP gives me a different address out of the pool. And now all of a sudden I can treat them as two different machines. So we have to be aware of that. When you run into problems with connectivity every once in a while with clones, it's because the MAC address was never changed, and so it creates obvious problems with a DHCP server. Okay, so now everything about SSH can be found in a particular directory. So let's go there right now. Whoops. So this is our directory. Now, one of the things that we can see here is that we've got our keys. But what we're interested in is the SSHD or daemon configuration. So I'm going to sudo, and we'll take a look at, oops. There we go. There we go. Now I put a couple of asterisks or exclamation points here in the parts of the file that are really important. You can actually change the port that you're listening on. Port 22 is the default, but maybe you don't want to have your SSH connections there because everybody knows that's where they are. You can also specify a whole variety of things associated with SSH, right? You don't have to store the keys in the normal place. You can pick a particular IP address that you're listening to or listening on the server. But for the next part of this build, what we care about is the X11 forwarding. Now, I'll talk more about that here in a second, but there are all kinds of things that we can do with our SSH server. But essentially, OpenSSHD is, or this config file, is pretty much ready to go when we get started. Now, there's even a way to configure this to not use keys, right? You can actually use just a username and password. It's not recommended, right? We want to use the keys, but that's really what we wanted to do here. X11 forwarding, we can specify a port. Let me see, is there anything else that popped up here? I think one of the other things I wanted to mention was that there's a long history of avoiding telnet as root or SSHing as root, right? You don't want to do that because you're potentially causing a security hole where somebody might discover how to get root level access to your machine. All right. So I'm going to get out of that. That's pretty much all that I did there. But the other thing that we want to be aware of is that on the client side, we also have a configuration file. So in here, right, we want to be able to do X11 forwarding for our next step. Okay. Well, let's try that. Let's try the X11 forwarding side. So the whole point here now is that I want to get the desktop of the destination. Now, the crazy thing about this is that I am running SSH, which we normally think of as a terminal-based connection. And that's actually what we're going to do. But what we're now going to do is we're going to ask to be able to run GUI, or graphical user interface, programs over what we normally consider a text-based communication. And the magic there is that we're going to do X11 forwarding, which we allowed on the server. We've got it on this end, and so let's see what happens. Okay, friends, the video is getting a little bit long, so I thought I would cut it right there. But as you can see, we're going to pick right up when we get back with a little OpenSSH PSA. If you're getting a little confused, don't worry, stick with it. This is networking. You can do this, and may your packets always reach their destinations.